Alright, in this video we're going to be looking at the product and quotient raised to a power rule. So let's take a look at this situation. I'm going to give you a problem very similar to one of the ones we did before, and but a little bit more complex. So let's take a look. Say we have parenthesis and we have negative 5 x squared times y close parenthesis to the power of 2. So we have this problem here, and there is something unique about it. One of the things that's unique is, first of all, we have a negative 5. We have a negative sign that's in front of our integer. That does change a few things, and I'm going to explain to you why. So if we were to write out what we're going to do, remember when we have that power, that external power, it's just going to be multiplied to each term inside of the parentheses. So it's going to be multiplied to all three of these terms, negative 5, x squared, and y. So when we multiply it to negative 5, since the negative 5 was inside of parentheses, we need to make sure that anything that carries that negative sign stays inside of parentheses, because it will actually make a difference when you're working it out. In other words, just to show you, and you probably already understand this concept, but I think it's worth looking at since we're in this situation. If I were to just say negative 5 squared, it gives me negative 25. But if I were to say negative 25 inside of parentheses, or rephrase that, negative 5 inside of parentheses squared, it's going to give me a positive 25. So if we're using this particular rule and our negative integer is inside of a parenthesis, make sure that when you write it and you multiply that power to it, that it is also still remaining inside of a parenthesis. So what we really have is we have the negative 5 inside of a parenthesis times, right, that was to the power of 1 being multiplied by a power of 2. And we're literally just multiplying this power of 1, negative 5, by the power of 2. And then this whole term is going to be multiplied to our x squared. So then we have x squared times the power of 2. And you may be noticing, you may go, well, Mr. H, how come you didn't put parentheses around this x squared? Well, the reason I didn't put parentheses around this x squared, I could if I wanted to, but I didn't, because it's not going to make a difference. Since x is a positive variable, its coefficient is positive, then there's no need to put the parentheses, because it won't alter its value once we go ahead and perform this function. So let's go ahead and we'll put the next term. The next term is y. Notice that y doesn't have any power, so it's implied that it's a power of 1, and then times that power of 2. So hopefully this makes it look a little bit simpler how it's drawn out. So let's go and refine it. So we already said negative 5 to the power of 1 times the power of 2 just gives us negative 5 to the power of 2 times x to the power of 2 times 2 is 4 times y, and then 1 times 2 is 2. And now we're ready for our final step of refining this. So negative 5 squared, we already realized that with the calculator that's a positive 25, and then we have times x to the 4th, and then we have times y to the 2nd power. And that is our final answer for this problem. And now we're going to go ahead and we're going to do one using the quotient raised to a power rule. Alright, on the quotient raised to a power, let's go ahead, we're going to do one that looks a little different than what we've done before. So let's say we have x over y, all in parentheses, to the power of 4. Okay, so looking at this one, you might go, okay, well this looks a little bit different, but so what are we going to do here? Well, one thing that I see a lot of people do is they forget to carry out this power properly, and I'm going to show you what I mean. This has a power of 4. That power of 4, it does not just apply to the numerator. You also have to carry it down to the denominator, and that's usually the mistake that people make. You will forget to carry it down to the denominator, and so you'll get the wrong answer. So if we were to work this out, it simply becomes x to the power of 4 over x, or I'm sorry, over y to the power of 4. And if you wanted to see the process, right, because this is a power of 1, so it's just 1 times 4, and then this is a power of 1, so it's 1 times 4, and that's how we get those powers. So I'm going to show you one more example of this just to make sure you got it. So let's do one a little bit more complicated. So let's take a look at this one. Let's do 3 to the power c times a to the power of 3 over b to the power of 2. And we're going to use this same concept in order to answer this. So our first step, we have one of these, and let's go ahead and let's add some parentheses and say times the power of 4. This is going to be more likely what you'll see on the star. So when we have this, what we need to do is make sure that we apply this power on the outside to each one of these terms. So it needs to be applied to the 3. It's going to need to be applied to this 3. And it's going to need to be applied to the 2. So if we were to do that, and we want to see what it looks like, we would end up with 3 to the power, and I'm going to put it in, and notice I'm not going to put this one in parentheses. It is integer, but it doesn't have a negative sign, so I'm not going to worry about putting a parenthesis. So I'm going to have 3 to the power of 1 times the power of 4. The next term is going to be this. That whole thing is going to be multiplied times a to the power of 3 times the power of 4, and this whole thing is over b to the power of 2 times the power of 4. And this way you can see the entire process. All of this is taking place. Now if I were to rewrite this and clean it up a bit, what I would end up having is 3 to the power of 4 times a to the power of 12 over b to the power of 8. Now we're almost done. I'm going to move it up just a little bit so we can write our final answer. And if you're going, well, why doesn't this look done? You know, if you're wondering that, remember that we have an integer, right? We have a base that has a power of 4. We can do something with that. We can go ahead and calculate it. Now I don't know in my head exactly what that is, but what we can do is we can put it in our calculator, right? We can say, okay, we have, well, 3 to the power of 4. What is 3 to the power of 4? So we 3 caret 4, and we'll hit enter, and it gives me 81. So that took care of that. So this 3 to the power of the 4, we went ahead and worked it out, and it became 81. Now when we're looking at the a, right, this is a variable. We don't know what its value is, so there's nothing we can do to it. So we're just going to bring it down. Times a to the power of 12. And same thing with the b. There's nothing we can do to it. So b to the power of 8. And now this answer is complete. Was it a lot of steps? Yes. Did we have to be careful? Yes. Did it help to write it out? Absolutely. So on these, until you get really efficient with them, I want to make sure that you're writing them out. In class, you need to be writing the steps out so that I can see that you understand the process.